Good afternoon, everyone. So, welcome to my YouTube channel, Math Saptram. Hope all you people are good and you are doing well in your life. So, today we are going to see few questions on uniform convergence of functions. This is problem set 1. Okay. So, let's start today's session now. So, what is first objective question? First objective question in front of your screen is f(n)x is given 1 upon 2n plus 2nx plus 1 and gnx is equal to x upon 2nx plus 1. Okay. So on the open interval 0, 1, consider the following statement. The sequence fn converges uniformly on 0, 1 open interval. Second is the sequence gn converges uniformly on open interval 0, 1. Then you are given fourth option. Number 1, A, first is true, B is second is true, first is not true, C is first is false, second is true, D, both first and second are true. Okay. So let's see. So you see that you have f(n)x function. So what is its pointwise limit? Because if pointwise limit is not existing, function will be not uniformly converged. So first find its pointwise limit. Okay. So if we take any x belongs to 0, 1, okay, 0, 1, what we have? We have this implies f(n)x 1 upon 2 and x plus 1. Where it will go? Because x is non-zero. So 2 and x will go to infinity as and tending to infinity. So where it will go? It will go to 0. Okay. So for all x belongs to open interval 0, 1, we have limit is tending to 0. It means pointwise limit is 0. Pointwise limit. Okay. Now, what is fn minus gf? What is this? This is 0, so this is f(n)x. This is 1 upon 2 and x plus 1. Okay. So I know that 1 upon n, if I take x is equal to 1 upon n, belongs to 0, 1 for all n greater than equal to 2. So if I am putting xn is equal to 1 upon n here, so what is this f and xn? What is this? 1 upon 2n into 1 upon n plus 1. That is 1 upon 2 plus, that is 1 by 3. So we cannot make it smaller than epsilon, because if we take epsilon is equal to 1 by 3, it cannot be smaller than 1 by 3. So it means, or I can take epsilon is equal to 1 by 4. I cannot make this less than 1 by 4. It means my fn do not converge f uniformly. So f do not converge, does not converge uniformly. So, okay, first statement is wrong. First statement is false. Now what about gnx? gnx. You see that gnx is 1 upon x upon 2 and x plus 1. Here is x also. So if because function is positive, if and denominator is also positive. See, if I skip 1 here, it will be 2 and x. I can cut down 1 of x. So it will 2. Now this is free of x and it tends to 0 as n tending to infinity. And does not depend on x. It means gn tends to 0 function uniformly. So second statement is true, but first is false. So which option is correct? This statement is not correct. We have proved. And this statement is correct. So both statement is correct. First is false and second is true. C option is correct. Okay. So we have C option is correct. Okay. So we have done question number 1. Okay. Now we move to second question. Now we move to second question. Fnx is 1 upon 1 plus nx square. Which of the following are true? Fn converges pointwise on 0, 1, 2. Continuous function. Second one is Fn converges uniformly on closed interval 0, 1. C option is Fn converges uniformly on closed interval 1 by 2 to 1. And this limit is equal. Okay. So let's see it. Okay. So if we take any x belongs to R, f and x, what will be its pointwise limit? Because if x is 0, either x is 0 or x is non-zero. When x is 0, this implies f and 0 is 1. Okay, this will tends to 1. It means f at 0 is 1. Okay. Now what about if x is non-zero? If x is non-zero, then what is f and x? 1 upon n x square. Because when x is non-zero, then x square will be tends to infinity as n tending to infinity. So where it will go? It will go to 0. It means fx is 0 if x is non-zero. Okay. So what we got? Fx is equal to, it is 1 if x is 0 and it is 0 if x is non-zero. Okay. Now observe one thing. If a function converges, if you have a sequence of functions that is continuous, each fn is continuous, and if it converges uniformly to some function, that function is also continuous. But here we know that pointwise limit is not a continuous function. This is not a continuous function. Okay. But each fn is continuous. What does it mean? It cannot converge uniformly. So option number A is not correct. Okay. We have eliminated option number 1. Now fn converges uniformly on 0, 1. Okay. Fn converges uniformly on 0, 1. Okay. Now see this. Suppose I am taking this one. I am taking 1 upon under root n. So this is not a 0 function. So this is not a 0 point. But what is fn? What is this? 1 upon 1. Sorry, n. 1 upon under root n square plus 1. That is 1 upon 2. And what is fxn? Okay. So 1 minute. Let me. Okay. So this is 1 by 2. Okay. Now what about this? Fxn. Fxn is 0 because xn is non-zero. So what about fxn minus fxn is equal to 1 by 2 minus 0. That is 1 by 2. If we take epsilon is equal to 1 by 3, we cannot make this part, this value is smaller than 1 by 3. It means fn do not converge to f uniformly. So this means we have that function do not converge uniformly. Okay. So this option is not correct. Because this belongs to, because this point, because 1 upon under root point xn belongs to closed interval 0, 1. So function is not uniformly on closed interval 0, 1. Okay. So this is, but function converges uniformly on this because when fn is 0, then f0 is also 1. So this is 0. When x is not 0, then what is fx minus fx? What is that? This is 1 upon 2, nx square plus 1. Okay. So on 1 by 2, on closed interval 1 by 2, we can, this is 1 upon n square. I can take 1 upon n 1 by 2 x. This is 4 upon n. That tends to 0 as n tending to infinity. Okay. So it means F1 converging to F uniformly on 1 by 2. Okay. Because on this interval, on this interval, sorry, 1 minute, let me write again. Okay. Because on this interval, closed interval 1 to 1 by 2 to 1, what we have? 1 by 2 to 1 we have, my f will be 0. So f and x minus f is 0 on this interval. F and x is 1 upon n x square plus 1. Okay. So this is less than 1 upon n square. I can take 1 by 2, so it will be 1 upon n 1 by 2 square 4 upon n. That tends to 0 as n tending to infinity. And it does not depend any x. So f n tends to 0 function uniformly on closed interval 1 by 2 to 1. Okay. So option number C is correct. Okay. Now this will not hold because D option will not hold. Why? You see that option number you can check will not hold. Why? Because 0 to infinity limit f and x. What is this? This is fx. This is fx. Fx is it is non-zero at one point. Then in that case its limit will be 0. Okay. If a function is non-zero at one point except it is 0, then limit will be obviously 0. And what about this limit? 0 to infinity f and x. Okay. So this will tends to infinity. Okay. You can check. So this option is not correct. And when limit and tending to infinity, it will also tend to infinity. So this option will not correct. This will be correct. Option number C is correct. Okay. Now what about this? Okay. What about this? This question is given. You check that each n belongs to n. Fn is a continuous function. You can check, and this is a continuous function. Okay. Continuous function. This is a continuous function. What is its pointwise limit? Pointwise limit when x is equal to 0, it is 0. When x is equal to 0, f and x 0 is 0. So it will tend to 0, that is f0. If x is not equal to 0, by Archimedean property of real numbers, there exists n belongs to n such that, okay, because we are taking closed interval 0, 1, x is not 0 means what? X is not 0 means what? It is positive. Okay, because we are taking x belongs to closed interval 0, 1. By Archimedean property we have, okay, by Archimedean property, okay, and this is less than equal to 1 because we are taking x closed interval 0, 1, x is non-zero, it means x is greater than 0 but less than equal to 1. So by this interval, definition of f and x in this interval, we have, okay, so by this what we have, because if we take any n, any n for all n greater than equal to capital N. This implies 2 upon n. Now by definition of f and x in this interval, subinterval, what we have by this f and x is 0. F and x is 0 for all n greater than. So this implies this tends to 0. So fx value is this. It means your f point-wise limit is 0. Point-wise limit. Okay. Now fn is continuous function. Fn is continuous function. So it is Riemann integrable also. Its point-wise limit is also f. That is also Riemann integrable. If fn converges to uniformly, then integrals will also converge. If we can show that integral do not converge, function cannot converge. Okay. So check that. So what is the limit a to b? Sorry, 0 to 1 f dx. That is 0 because f is 0. And what about this? You can check that 0 to 1 f and x. This is coming 1. You can check. So it means 0 to 1 f and dx do not converge to 0 to 1 f dx because this is 0 and this is 1. So it means f and do not converge to f 0 function. That is my f uniformly. So f and do not converge uniformly to 0 function. Okay. It means f. So which option is correct? F and do not converge point-wise. Obviously it converge point-wise. So it is not correct. Converge is uniformly. Yes, it is. It is not correct. It is not correct. Okay. So we have done it. Okay. In this question, third, it was given that function is defined in subintervals. And you can check Fn is continuous function for each n. And its point-wise limit is 0, that is also continuous. Continuous function are Riemann integrable. If Fn converges to f uniformly, integral will also converge. If we can show that integral do not converge, Fn cannot converge to f uniformly. That idea we have used over here. Okay. Now, fourth question. Fourth question. Fn x upon x e power n upon n. Okay. Okay. If x is 0, then what is f and x? F and 0, that is 0. It means f, it will tends to 0, that is f is 0. If it x is equal to 1, then what? F and 1, where it will tends to x 1 minus 1 upon n, that will tends to 1. And f 1, it is 1. Okay. And what about this? If x is in this interval, then f and x minus x to the power n upon n. This part will tends to 0, it means it tends to. Okay. It means f is nothing but this function fx is equal to x. Okay. So what is fx is equal to? Because at 0 it is 0, 1 at 1 it is, otherwise it is x. So this function. So now f and x minus fx, that is x minus x to the power n upon n minus x. X is cancel out. It will be x to the power n upon. And it is defined on closed interval 0, 1. So I can take maximum value. This tends to 0 as n tending to infinity. So it do not depends on x. It means fn tends to f uniformly. It means It means Fn tends to F uniformly. Okay. So function, this is converges uniformly. Sequence of function converges uniformly. Okay. Now, what about derivative? Okay. What about derivative function? Derivative function is, what is that? Fn x is equal to x minus x to the power and take derivative. It has 1 minus n x to the power n minus 1 upon n will be cancelled. Okay. So derivative function is this 1 minus x to the power n minus. Okay. Now, this is a continuous function. Fn dash is continuous for each n. Okay. For each n, it is continuous function. What is pointwise limit? When I take Fn dash 0, what is this? This is 1. So this tends to 1. Fn, F. Okay. So pointwise limit at x is equal to 0 is 1. Okay. And when you are taking x in this range, what you will get? You will get Fn dash at x that it tends to 0. Okay. Let's say it pointwise limit is, what is pointwise limit of Fn dash? What is this? This is 1 if x is 0 and, x is 1. Sorry. 1 minute. I'm making mistake. Sorry. When I am taking x is equal to 0, the limit is 1. When I am taking x in this range, then where it will tend? Because this is less than 1, its power will be decreased and finally it will converge to 1. Okay. 1. So let's say pointwise limit of g Fn dash derivative is g. So what is g? Gx is equal to 1 for all Fn after 0. So what is this? Now Fn dash minus g. That is, what is that? 1 minus x to the power n minus 1. This will cancel out. X to the power n minus 1. Okay, I can take x is equal to 1. If I can take then Fn dash minus, this is 1. I cannot make this smaller than epsilon by 2. So it means, what does it mean? It means that 1 minute, I'm still making a mistake, sorry. When I am taking, I use different idea. When I am taking 0, it is giving me 1 minute. Let me check it again. I'm making mistake again. Sorry. Fn dash, when I am putting 0, then what about this? So first of all, you take x is equal to 1, then what will happen? This is 1, x to the power n minus 1, it is 1. So that is 0, it will tend to 0. Okay? It will tend to 0. Now if I take my x, in this range, then what is this f1 dash x? Because when your x is either 0, infinity, 0 and 1, x to the power n minus 1 will tends to 0, and this will tends to 0, this will tends to 1. Okay. So what is pointwise limit? Limit of f1 dash, that is 0 if x is equal to 1 and 0 if x belongs to open interval 0, close interval 0, 1 open. This is 1. Okay. So you said that this function is not continuous at all, but f1 derivative function is continuous. So f1 dash cannot converge uniformly, because if f1 dash converge uniformly, each f1 dash is continuous, its pointwise limit function will, its uniform limit will be also continuous, but this pointwise limit is not continuous. So f1 dash cannot converge to this limit. It means, okay. So it means f1 converges uniformly, but derivatives do not converge uniformly. So which one is correct? f1 converges uniformly on 0, 1, but this not converge. Sorry. This option. This is not correct. This is not correct. Okay. So I was making mistake one again, and so f1 dash at 1, it is 0, limit is 0. And when you are taking x in between 0 and 1, or x is equal to 0, the derivative limit, pointwise limit is 1. So the pointwise limit is not actually continuous function, but derivative functions are continuous. So derivative functions cannot converge this function point uniformly. Otherwise, if they converge, it has to be continuous, but it is not continuous. So f1 derivative cannot converge to this function uniformly. Okay. So we are done with this question. Now what about this? Now f1x is equal to log 1 plus n cube x square upon n square. Sequence is given. So fourth option are given. Both f1 and its derivative are uniformly convergent on 0, 1. f1 is uniformly convergent on 0, 1, but derivative is not uniformly convergent. f1 is not uniformly convergent on 0, 1, but derivative is uniformly convergent on 0, 1. Both f1 and f1 dash are uniformly convergent on 0. Let's see it. So what is f1x? What is f1x? f1x is log 1 plus n cube x square n cube and n square. Okay. This function is given. Now you see that on closed interval 0, 1. Okay. Now if we take f1 0, what is this? Log 1 upon n square. Log 1 value is 0. So this is 0. This tends to 0. It means f1 0 converges pointwise, at least 1 point. Okay. What about derivative function? Derivative f1 dash is equal to, what is this? 1 upon 1 plus n cube x square. Its derivative n cube 2x and n square. So this is 2 and x upon 1 plus n cube x square. Okay. Okay. Now what about this? What is the pointwise? What is this? So I am saying that fn x is equal to fn dash x. Okay. Okay. You see that for each fixed n belongs to n, limit x tends to plus minus infinity, g and x is tending to 0. Okay. Now we will find maximum of this function for fixed n. Let n be fixed. Okay, n be fixed. First, you tell me what is the pointwise limit of g and x? This is my x. What is pointwise limit? Limit n tending to infinity. What is g and x? Tell me. This is 0 because when x is 0, it is 0. When x is non-zero, suppose x is 0, then what will be this? Limit g and 0. But g and 0 is 0. 0, 0. So g0 is 0. Okay. Okay. When x is non-zero, when x is not 0, x is not 0, then what about limit g and x? That is to take this. So it is 2nx 1 plus n cube x square. So I can remove 1 here from here. 2nx n cube x square. So that is x. So 1 n square. So this is 2 upon n square. That tends to 0. Okay. It means your g function is 0. So gn converts to 0 function uniformly. Sorry, pointwise. 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 It means gn derivative function converts pointwise to 0 function. Now for we are taking fixed n and we will calculate maxima and minima of okay. So we will use what is gn x. We will calculate this supremum. That is mn for fixed n. It means supremum of what is this? 2nx. Okay. But this is even function. Okay. So what is gn(x)? 2nx upon 1 plus n cube x square. So take derivative of this function and calculate critical points. Critical point. Okay. gn dash x is equal to what is this? 1 plus n cube x square. 2n will come out. Derivative x is 1. 1 plus n cube x square minus x. Derivative of this. What is this? N cube into 2x. After solving, what you will get? 2n, and that is 1 minus n cube x square. Okay. 1 plus n cube x square. So where gn, when will be to 0? If and only x is plus minus 1 upon n to the power 3y. Okay. So what is this? Now, what is mn? mn is supremum of 2nx 1 plus n cube x square. Put these values. So what will be supremum? supremum will be equal to, put this value, it will be 2 upon, and we put this under root n, and in denominator it will be 2. So 2 cancel out. So what is, and this tends to 0 as n tending to. Okay. So when mn tends to 0 as n tending to infinity and independent of x, it is independent of x. So when, so mn tends to 0 as n tending to infinity, it means what? Gnx, Gn converges to 0 function, it means G function uniformly. It means what? Derivative function converges uniformly. We know a result. If fn converge on a closed interval AB, closed interval here is 0, 1. If fn converges pointwise at least one point and derivative function converges uniformly, then fn also converges uniformly. Okay. So fn and fn dash both converges uniformly by conclusion. Okay. Because we have done this lecture. You can see our playlist on lectures. Okay. Uniform convergence of functions. You can see playlist. I have done one result that if fn converges pointwise at least one point on a closed interval AB and derivative function converges uniformly on closed interval, then fn also converges uniformly. Okay. So fn and fn dash both converge uniformly. Okay. So which option is correct? Option number 1 is correct. A is correct. Okay. Okay. A is correct. If you want to see that, result, you see our playlist on uniform convergence of functions. You see all the lectures. You will find somewhere. Okay. Maybe I have given just 2 or 3 lectures before I have delivered that lecture. Okay. You can see. So today's lecture up to this. Okay. We have done some problem on uniform convergence. Okay. So like, share, comment, and subscribe my YouTube channel. If you have any problem related to this session, you can give me a comment on my YouTube channel. I will see and I will discuss in next session. Thank you very much for today's session. Thank you very much.